Hello, welcome back to my channel. This is Mac Tech, and let's jump right into it. So today, we're going to do a continuation of the Skills Project series that I started a couple weeks ago. And today, we're going to focus on addressing the network devices that you see here that I've boxed in. It's going to include the routers here in the middle and the switches that connect to our host devices. First things first, I'm just going to go briefly over the configurations that I've already made. Okay, so what I've done is I've ran the IP interface brief command, which shows the mappings between interfaces and IP addresses, and I've done so for IPv6 as well. And if you look here, you'll see that I have configured what are called sub interfaces, which are essentially logical interfaces that share one single physical interface. And you'll also notice that even though even though the numbers are the same on either side, these are the same, represent the same VLANs. The IP addresses are different, and the reason for that being is for now we are not going to have hot standby ready protocol or HSRP, uh, which essentially creates a virtual default gateway that is shared between two devices. We're not ready to set that up yet. So for now, we're just going to leave them as separate, and they'll stay separate until we apply HSRP. And once we do that, both of these devices, from the perspective of the hosts, will be, for instance, instead of 192.168.0, it would be dot one at the end here. And no matter which one the hosts are looking at, whichever router, it would have that same address. But we're going to worry about that later. I just wanted to explain why they're different, because usually you'd think that all default gateways on the same VLAN would be the same, but not in this case, at least for now. Okay, so let me get my other router back up here, and then you'll notice. Oh crap! I don't know why it always does that. Okay, then you'll notice here it's the same thing essentially with IPv6. You'll notice that these addresses are going to end in a colon 2, and these ones end in a colon 3. So no biggie there. Same thing, just different, obviously different syntax. Let's see. So now we're going to go down to the switches here. So IT switch 1 and IT switch 2. And remember that this whole section here represents the IT office, and this section up here represents the corporate office. So just keep that in mind. This is supposed to be the same physical location, everything that I have boxed in right now. Okay. So open switch 2. And then the same thing as before. I'm just gonna start over here. Let's go. Show IP interface brief. Show IPv6 interface brief. Okay, perfect. All that really matters here with these switches are essentially the VLAN 22 IP address. As you'll see, that is the only IP address on the switch. Now, with the VLAN 22, what that is essentially is the network management VLAN. If a user over here at corporate or from the help desk or from the help desk here wanted to remotely manage or configure these devices, they would have to go through the VLAN 22 the VLAN 22 IP address in order to do so. A user will not be able to use SSH or Telnet to configure a device unless there is a layer 3 address on it. And typically, what this is called is an SVI, which stands for Switch Virtual Interface. So and in order for that switch virtual interface to have an IP address, you have to use a VLAN. So that's what we've done there. And then you'll notice too, it's the same thing for IPv6, just obviously slightly different syntax here. But you'll notice they are different. These are different IP addresses, and they will stay that way. It's not like the routers that I mentioned before. Okay, so done there. Now I didn't go over this before, but we'll go over it. I only mentioned the sub interface IP addresses. However, obviously we also have these IP addresses as well. You'll see serial 00 goes to the corporate router, and then serial 001 goes to IT router 2. And I purposely addressed it this way to be classful because this connection right here represents a WAN connection between the switch, or sorry, the IT router 1 and the corporate router. Because they're different offices, I had the thinking of essentially this office down here would be essentially a satellite office that connects to the corporate office. And this connection that you see here with these two lightning shaped cables could represent like a few miles, maybe other side of the town, or maybe a different state. It's an unspecified distance, but it falls under the umbrella of a wide area network. Okay, and I addressed this connection here between IT switch. Sorry, I keep saying that. IT router 1 and IT router 2. I configured that with a 192.168 address because I wanted to represent the fact that this is local. These are probably a few meters, maybe a few feet away from each other, and we don't necessarily even need to have a serial cable here. But I just thought to keep it consistent. Um, However, yeah, I just want to make sure that it was clear that these two are much closer than either of these are to this router. Okay, just want to make that known. So yeah, that's why there's a difference in addressing here. So we'll go ahead and leave IT router 1 up. And what we're going to do now is configure the addressing on serial 0 on the corporate router. So I already know the schema of the network here. So I'm just going to, for the sake of time, I'm going to just go quick. Looks like I already started this, but essentially I took this address here and I added 1 to the end of it, as you can see here. Instead of a .1, it's a .2. And this is a /30 network, right? So /30 network is going to give you 2 usable host addresses, and that's all you need because there's only 2 points. It's called a link-to-link connection here. Okay, now we're going to do IPv6. So if you look, you'll see IPv6 address here. So I'm just going to copy that. We'll do IPv6 address, paste, and then we're gonna, just like we did before, we're going to change that 1 to a 2. Okay. Oops. Oh, and for you don't have to add the subnet mask written in decimal format. Here you would just put a /64, and that will suffice for IPv6. Okay. And let's see. Now what we're going to do is we're going to take this. We're going to take this address and we're going to ping it from our corporate router. Ping. Put in the number. And it's success. Okay. So that verifies that we have end-to-end connectivity here. And then we're going to do the same thing with the IPv6 address. Copy, ping, paste, boom. All right, good. So we've verified connection here. Now we are going to move on to IT router 2. So we'll close this out. IT router 2, bring that up. Okay. So if we can just scroll up here. Yep. Okay. So we'll do IPv4 first. We'll go back into configure terminal, do interface, and then here you'll see it's serial 1. So we'll do IP address, And then here we're going to paste this address. Oops. And I just know because off the top of my head, I've already been familiar with the network. I know this is going to be 5. So we'll just add that. And same thing, it's going to be a /30 notation. And then we'll do IPv6 address. Find what serial 1 is addressed here. We'll copy that in. Oops. Take that a 1. Oop, forgot it again. /64. Okay, no shuts. And we'll do this. We'll do end. Now, same thing, we're going to ping to test connectivity. So I'll grab this address here. Ping, working there. And then ping is working there. Cool. So now we have connection here between these 2 devices and these 2 devices. Now I didn't walk through it. I didn't walk through configuring it rather, but let's just test connectivity between IT router 2 here and IT router 1, and then between IT router 2 and the ISP gateway. We'll log in. We'll do show IP interface brief, and then we'll do v6. Okay, and we'll do IPv4 first. So I'm going to ping IT router 1, right? So let's see. This will be from the S0 to S1. So S0 is 192.168.3.2. Copy that and subtract 1 because remember, we can't just ping our own, if we ping our own interface, it doesn't help us at all. So I just know that this one is .1. So cool, we have two-way connection there. Now let's copy and paste the IPv6 address. Same thing, take the 2, add a 1, and perfect. So we have connection there as well. Now we'll see gigabit 01. What do we have configured? Okay, it's like a 216 address. Copy that. And then we're going to ping the 212.9, or we'll change that to a 10 rather. And then we have connection there. And we'll copy the IPv6 address. Change that to a 2, and we have connection there. So great, we have connection between all of our directly connected routers. Okay, so we're good there. Now what I want to do on all these routers, just to make sure that we don't lose our progress, we're going to copy the running configuration to the starting configuration. Running configuration is stored in RAM, so it's volatile. If the device shuts off, we lose our progress. But if it's saved to the startup configuration, it's going to be saved in NVRAM, non-volatile RAM, and we'll still have our configurations if the device for whatever reason reboots. So we'll do that. Hit enter. Great. We'll do another way we can do it too is write memory. It does the same thing. I'll do that here as well. And I don't need to do it on this one. Okay, perfect. So you have the routers configured with their IP addresses, except for the sub interface, right? So we have G00 facing our switch and our hosts. So we're going to need to find the IP addresses for these VLANs for their default gateway and add them to the sub interfaces on gigabit 00. All right. Configure T, interface G00. And then I need to scroll down. I don't have these memorized. what I'm doing here is I'm finding them in my addressing scheme that I made up. Okay, 21. Okay, 40. I'll make sure that they're all here. Bear with me. Okay, I got it. All right, so first things first, interface G00. We're gonna, on this interface by itself, all we're gonna do is make sure it's on. So we're gonna do no shut here, right? So we know it's on. No matter how many sub interfaces you configure, if it's off, it is not gonna work. So now we're gonna go a little deeper. Go interface G00.19, and this is gonna be the default gateway for our VLAN 19 up here. Okay. And we'll go back to our corporate router. So first command you need to put here is encapsulation .1q 19. Now this command does is it enables the protocol that enables sub interface configuration to occur, and that's this .1q. That's the protocol that we use to allow for sub interfaces, right? Okay. So now we'll configure IP address. I'm just going to be doing copying and pasting. So it's going to be 168.0.20. And this is a /27. So 255.255.255.224. Okay. IPv6 address as well. Again, I'm just copying and pasting from my document here. And also a /64. All right. And then next, what I'm going to do here is I'm just gonna keep hitting up. I don't have to do the full command again and risk a fat finger. Okay. So now I'm going to do .40. That's obviously going to represent the VLAN 40 for sales. So we'll do encapsulation .1q, and then you see on the end there, I forgot to mention before, but that number 19 or whatever you put, I mean, you can put whatever you want, but typically you're going to want to associate it to the VLAN number. That's the most logical thing to do. So we'll just do 40. IP address here is going to be 0.90. Oh, sorry, not 90. It's going to be 2.1. And this is going to be a 120/125. So instead of 224, we're going to do 128. IPv6 add. IPv6 add. Okay. Then we'll go to 40. We'll do 41 next. And just a 41. IP add. And this is going to be a /26, which is a 255.255.255.192. IPv6 add. Excellent. Okay. And so we got a couple more. So interface 42, encapsulation, .1q42, for add 2.193. This is going to be a /27, so it's 224 for the last octet. IPv6 here is going to be 8::1. Also, I'll mention briefly this number here. You'll notice that's the only number that's changing in the address. This number here is the sub-interface number. This would be the host number. This would be the network number. I got one more. Isn't that fun? This one has the same slash notation, so I'll leave it as is. And then we will do one more. IPv6. And I just realized I messed up the last one, so we got to go back. I'll have to do, so this is what I had last time, so I got to hit no. I have to hit, I change this to a 7. Okay, perfect. And then we'll go back to our other interface. Okay, cool. All right, so let's hope we did it all right. We can verify that. Okay, we got 19, 40, 41, 42, 43. All right, that looks good. IPv6 interface brief. Looks good, looks good, looks good. Cool. All right, so we're ready to save now. So I'm going to do copy, run, start, enter. Okay, excellent. So we got all of our routers configured now. All right. Now we got one more thing to do. That's going to be to configure the SVI on our corporate switch so that we're able to remotely manage it when we need to do so. Let me scroll down on my addressing sheet here. Okay. The first thing we need to do, we need to go to configure terminal. We need to create the VLAN. So all we're going to do is to do that is just enter VLAN 22. We're already in the VLAN configuration here. Now we're going to add IP add, and it's going to be .86. In this case, we have a /28, 255, 255, 255, 240. What's going on here? Oh, hold on. Okay. Okay, here's what I did wrong there. So I just put VLAN 22, so I created the VLAN on the switch, but it didn't actually bring me into a configurable VLAN. So I was in the VLAN here, and I could have added a name or something, but I was not in the interface VLAN interface configuration mode, right? So that's why you see down here where it says interface, and you see where it says brought to up, and now let me add the IP addresses, okay? And I don't think it's going to let me add an IPv6 address, but I'm going to try. And I'll tell you why in a second here. Yeah, okay. So this is something that I forgot to mention in my initial configuration video. There is a command that we or I did not remember to include in that. So I'm going to go ahead and run it here. But before I do that, I'm going to do a write to memory, and this is the command that I forgot to put in my initial configuration. Ready? SDM prefer dual IPv4 and IPv6 default, right? So this what this does is it turns the switch into a what's called a dual stack switch, which allows for IPv4 and IPv6 addressing. Without this command on at least this model switch, which is a 2911, you're not going to be able to put an IPv6 address on there. Okay, so I'm just going to go ahead and run this real quick, and then you see right here it says you need to do a reload in order for it to take effect. So I'm going to go ahead and do that. Yes, we want to save, of course. And luckily we're in packet tracer, so this won't take nearly as much time as it would if we were on an actual device. Okay, great. Right back where we were before, right? I'm just going to take this command I had up here and just copy it. Great. All right. All right, there we have our VLAN 22. We have our VLAN 22 IPv4. All right, guys, thanks for hanging with me. Appreciate you staying to the end of the video if you did. I mean, wow, it's almost been half an hour. It's crazy how time flies when you're just having so much fun. Um, but yeah, so we have all the addresses of the interfaces assigned. However, if I try to go to my PC here and ping this network, you'd think like, oh yeah, we have our default gateway configured. I'm going to be able to move traffic easily, right? And that would be wrong actually. And the reason being is because we have not configured our trunk here. So our switch is not VLAN aware. So this interface G01 has not been set up to move multi VLAN traffic, and also we haven't set up our access ports on the switch itself. And I'm going to save that for another video, but the same would also apply on this side. And also too, if I wanted to, ping this router from this router, it wouldn't work. And to prove that, I'll go ahead and try it. Let's grab the IP address here. So we'll do ping, and then slap that bad boy in there. And you're going to see that it's going to fail, okay? And that's because we have not established routing yet. So the only reason we're able to ping these devices that are all connected to each other is because, for that reason exactly, they're directly connected. If we wanted to ping a device that is not directly connected, we need routing in order to get there, because this is technically a different network than this, right? The addressing schema is different. The subnetting is different. They're on a different logical network. Um, so we'll go over that in future videos. I mean, I'm really going to try and keep it shorter next time. I appreciate you hanging in with me if you did, and I will see you in the next one.